Thank you for coming to my talk. It's awesome to be in St. Petersburg. It was my first time in Russia. I came here via Siberia, which was phenomenal. St. Petersburg is equally just a beautiful, beautiful city. I'm very excited to give this talk here. So my talk is called Breaking News, a Web Performance Story. And it is the story of how we built one of the world's fastest websites in publishing, and the decisions we made along the way, and how and what they came to cost. Oh, I didn't count on that, sorry about that. Cool. So I'm Dora Militaru. I work for the Financial Times, which is a global news organization that's recognized for its integrity and authority and accuracy. What did I do in the FT? So at the beginning of this year, I was a tech lead for GDPR on FT.com. It's interesting. Currently, I work on an internal apps team building experimental, data-driven, and short-lived apps. It's very, very exciting also. I'm a JavaScript developer. I dabble into a few other things. Yeah, onto FT.com, which is my favorite part of working at the FT, although I no longer work on FT.com. I'm still very close to the department. And it makes me really happy to think about the history of the product. So, at first, in 2016, FinancialTimes.com looked a little bit like this. It was codenamed Falcon, which is very ironic, considering the time to first page was around 6-7 seconds. Then, it also took, we had monthly weekend releases. I say we, I wasn't there for this, but I can commiserate. Then we decided to rebuild it completely from scratch. Flip a big red button, and then came next, which is FT.com as we see it today. In 2017, it was crowned the fastest site in publishing the news. So it took less than 2 seconds to load on mobile and less than 1.3 seconds on desktop. It was really, really zappy. How are we doing today? Okay, first contentful paint is about 1 second. First meaningful paint, 1.22. Time to interactive, 1.97. Fully loaded, which we don't care about so much because we lazy load images, there's stuff under the fold. We have all the tracking and some third-party scripts that come in later. So we're not doing so well anymore. We used to be at the top of that leaderboard, which is the Hearst FP leaderboard. Why is that? It's because as products mature, performance becomes harder to maintain. Before I go into all of that, I want to talk about the anatomy of a request to FT.com. So what happens if you type FT.com into your browser? It's roughly this. So we look up FT.com in DNS. We have a content delivery network, and usually it doesn't just serve assets, it serves everything. We have a pre-flight service as a caching strategy. I'll explain in a moment what that is. Then we go to a router, and then we serve the app and all the various components that the user was looking for. Okay, DNS. We use Dyn. They're a no-server provider, and there are a single point of failure. But caching our domain name records should help with that during short outages. We have 2 main domains. The apex domain is ft.com, and we have 4 A records. They're pointing at 4 IPs. We have the subdomain, the www.ft.com. That only has a CNAME record, and that defers to our CDN for DNS resolution strategy. Now, in theory, these two should both result to the same A records with those 4 IP addresses, and you can see they all point to Fastly, which is the provider we use for CDN. Now, Fastly. We have for IP addresses, yet somehow we can route traffic to Fastly POPs, those points, their servers in 50 plus locations around the world. So how does that happen? How does Fastly know what the closest cache is and where they should serve our content from? They manage their traffic on the network using the border gateway protocol and anycast routing. I'll explain what that is. This allows them to send requests to the nearest point of presence, POP, while avoiding unplanned outages and locations that are down for maintenance. We have, so geographically, we have origins in the EU and the US, and that's it. So that's why we need a content delivery network to serve cache content in a way that is more efficient for users. Okay, anycast routing is like a network addressing and routing method in which data from a single sender is routed to any one of several destination nodes, selected on the basis which is nearest, is the backend healthy, is this the least congested route or the lowest cost route, or some other measure. And yeah, Fastly is this, it's very useful for us. They also route around outages in two ways. The first one is at the DNS layer, so they update their DNS records to avoid location which is problematic, and then there's network layer, which is the border gateway protocol that will then broadcast the path that a request's TCP packets will take between routers. Cool. Fastly stack. The normal Fastly stack is a two-layer system. So they have a HTTP proxy called H2O that's used to manage TLS termination, and then we have Varnish, which is a popular caching HTTP reverse proxy. We don't use H2O because we have to support IE, so that's TLS 1.0 and 1.1. So we point to a different bit of Fastly's infrastructure. We are one of Fastly's biggest customers, so we can do this. The Varnish bit, the Varnish bit is really, really interesting, and a lot of the magic that we do for web performance and FT.com relies on Fastly's custom implementation of VCL. So we have to read their manuals more than we have to read the VCL official manuals. So VCL stands for Varnish Cache Language. I'm not going to go into the request flow to a CDN, but it's basically a lot of subroutines that look up the cache, decide, okay, do we have this content? Is it cached? If not, what should we do with it? Is there an error? Etc. There's many things that you can hook into. And the most important bit that we hook into at Fastly is in the receive. So as the request comes in, we have a service called pre-flight that basically decorates every request with some metadata and then restarts the request to the CDN, and then we have a better chance of serving cached content. What is this pre-flight cached content? Why do we need to restart? Okay, so imagine that you have to serve as much cached content as possible and avoid hitting your origins, and do that in a way that is custom for every user. So a user will have a session, will have a location, unused dependent, so many things. Use will be different if you're in the States, ads will be different if you're in China, and so on and so forth. So we can't possibly cache every single one of those variations because you will have no cache. So what we then do is we have the pre-flight service that analyzes a bunch of elements on the request that matter to us, and then it serves a set number of headers, which we then vary on. So really we have full control of the cache fragmentation from this point onwards. We strip out everything else. So we'll be able to tell after pre-flight, once we restart the request, whether the user was authenticated, what edition of the paper they should be seeing, if they're in any multivariate test buckets, and so on. So as opposed to having something that is unique per user, we cohort users and we fragment the cache that way. And this allows us to cache up to 94% of all requests with a cache hit rate of 90%. So like, if we see something like 9 million requests during the morning spike, if we use the CDN cache, we only pass on about 900,000 of those to our origin applications, which means that we can maintain a more simple infrastructure and things don't blow up as often as they would. We also serve stale content, and this is a decision we made, so again, to protect origins in case of error and to protect the user experience. So Fastly allow you to have very fine control of how long that cache lives, what happens if the response is an error, etc. There are many response headers that you can use. We use stale while we validate and stale with error. So we've covered Fastly and pre-flight. What happens after Fastly? What if it's one of those requests that needs to go to the origin, it's not cached? We go to the router, which decides whether you're in the, also acts as a load balancer, so depending whether you're in the EU or US, will serve you a different origin. The router pulls a service registry, and you probably guessed by now because we have a service registry, also have microservices, and picks out the applications that the user needs to see and assembles them into a page. FT.com is actually made up of over 100 independent microservices. So that is going to cause very interesting quandaries when it comes to web performance. But more on that in a bit. So we've covered what happens if you go to FT.com in your browser. I want to look at the other side, which is what happens when you're building FT.com. What is the philosophy behind the engineering department? You have to be we had to adopt a set of principles to move from the sort of Falcon monolith implementation to what FT.com currently is, and be able to build and deliver and bake in performance into a process as we do. So, a number of sort of service architecture paradigms that people use. This is the monolith, this was Falcon, this is the front-end, back-end data store all living in a big application, everybody coming in on the weekend and doing a very long release with lots of coffee and beer. Then we have the front and back-end. So front-end is like one application that goes into the back-end, which is a big API that is maintained by a back-end team, DevOps team, that also controls the data store. We don't do that. We never have. And there's a classic microservice architecture. I think a lot of companies use this. So the front end communicates via an aggregation layer, so things like message brokering or GraphQL or backends for front ends, with a number of services that span across backend and data store. So those are the microservices. We went one step forward and we made it very political, and I think the paradigm we use in FT.com is micro frontends. So we have feature teams. We have a team that is in charge of the paywall. We have a team that is in charge of MyFT, which is the sort of the customized user journey bit of things. We have a team that is in charge of sign-up. So we have big feature teams, and they own everything from front end through the back end through the data store. And all of these teams have to make sure their services somehow fit into the FT.com ecosystem. Beyond that, we also have a highly componentized FT.com. This is to help with the teams a little bit. Where we have a component library called Origami that provides a unified design across all of FT.com, so all feature teams will use Origami. It's very well maintained, components are high quality. You can actually view the Origami registry if you're curious. It is open. In fact, a lot of other companies use Origami components. Market use it, Bloomberg use it. It's just a group of services, modules, and tools to help build websites, and we rely heavily on this to make things easier if you're building micro frontends. Big part of working on FT.com is a culture, and I like to think there's two key elements to our culture. The first one is courage-driven development. I made that up, but I'll explain. The second one is a free market software development. So yeah, courage-driven development. Mistakes happen, and you can choose how to make these mistakes. So very early on in my career at the FT, about a year and a half ago, I caused a massive outage in the paywall for a while, and it took about 20 minutes to fix, but it's huge because of the paywall. It's how we make money, and I was terrified of the consequences. I was still on my probation period. I was a middleweight developer, so someone would get in trouble. Why on earth was I even messing with the paywall anyway? And our technical director at the time came to my desk and he sort of sat down. I was like, okay, I need to show you an article. Let's find that way. So there's two types of teams. There's teams that make it harder to make mistakes. So typical response to this kind of incident is to go on defensive, like add more testing phases, hire testers for the paywall, or introduce some kind of mandatory code review process into our development cycle. Just, generally adding more bureaucracy to our releases to make sure that nobody could release buggy code and the paywall is Dora-proof. So this is a reaction driven by fear. The other way you can handle mistakes is to make it easy to fix them. So accept reality, people will always make mistakes. It's kind of a rite of passage in ft.com to break the front page. That's one I've never managed, but I've made plenty of others. Mistakes will inevitably slip through. So from that perspective, it's clear that what matters is to make it easy to fix mistakes. So the opposite, cutting down on bureaucracy, trusting developers to have access to production environments, and investing in test automation and continuous delivery, and rapid release cycles. So this is the reaction driven by courage, and this is at the very heart of ft.com. Yeah, our mission is to make it easier to release good quality software quickly, frequently, and with confidence. We release ft.com hundreds of times a day. In fact, Merge to Master kicks off a continuous integration cycle. It's a CI. We circle CI. The workflow is test, pass, deploy. Deploy goes to Heroku on a staging environment. The staging environment runs an automated smoke test. If that succeeds, everything gets promoted to production. This happens in 3-4 minutes, depending on your tests for the backends. It can be a lot longer for front ends. We have things like browser tests and all sorts of regression testing on the sign-up form, which is a key product. We also, to minimize risk, we also use something like dead man switches. So dead man switch is a switch that's designed to be activated if a human operator, say like in a nuclear facility, or in war, if they become incapacitated or are removed from control. So we have deadman switches for every feature on ft.com. And the purpose of these is something called software apoptosis. So apoptosis is the death of cells which occurs as a normal and controlled part of an organism's growth or development. The way feature flags work on ft.com is a remote set of switches that are usually on. So we build them behind flags. It's just like a wrapper around something. And flags have expiry dates, so after 3 months they expire, the feature disappears from the website because it's wrapped in this flag. And someone is asked to review it. It's usually the product owner asked to review it, and then they have to justify why we need to turn it off again. Forgot to review the paywall flag. Sorry, no paywall. Your own fault. And we absolutely abide by this. And it's really important so that we don't snowball, carry on with a bad, just like an ever-expanding code base and a set of features that aren't actually useful. If we can't justify it once it expires, it gets removed from the code base, it gets removed from the flags API, which just stores JSON saying like, this is what the feature does, here's where it lives, here's who's responsible for it. And that feature is forgotten about, never mentioned again. Ooh. we also punish dissent on FD.com. I'm in two minds about this. So we have the same stack across almost microservices. We use JavaScript, front and backend. Backends are mostly Node.js Express, or Node.js if it's just Lambda. We have a lot of shared tooling. In fact, we have shared tooling for just about everything, from linting to making sure we didn't commit API keys to production, to front-end build tools, and so on. And we rely on the same infrastructure. We use Heroku and serverless, largely Heroku, for all of our applications. Yeah. And even with this, teams are still encouraged to pick the best value tools for the job at hand. So, say, I don't know, maybe you wanted to use a graph database that we haven't yet procured for your backends. You as a team have the power to go through that procurement process without deferring to anyone higher up in the department. So, is that, whether there are things developed and supported by external teams like Neo4j, which is a graph database, or teams internal to the company, every team has the option of this, choosing to work with a product or not choosing to work with a product. So there's huge onus on our shared tooling and on our infrastructure decisions to be good and performant at any time so that more people use it. This also means that our internal teams are in competition with external providers and that they need to get smarter about what business need they're catering to and become more cost-effective to compete in this market and make it harder for people to, say, not use the FT's own content API and go somewhere else. Oh yeah, we have no QA. We decided to get rid of our QA capability in January, and ever since the onus has become that developers write sufficient automated tests to support the products. So far, nothing's blown up. Okay, performance. I don't know how you feel so far, but you can see it's like a complicated beast. There's the whole microservices part that goes into it. There's a whole software development philosophy that means that we have to adopt specific approaches to web performance on FT.com. So there's lots of good bits because we did manage to build a very performant website. Even if it's not at the top right now, it's still very performant. That have trade-offs. So yeah. Okay, microservices cause performance bottlenecks. So the pre-flight service I mentioned earlier on, which runs on every request to FT.com, looks at a user's combination of request headers, cookies, and so on, sends them off to a lot of other services. We check if the user's authenticated, we check if the users have access to a specific resource, we check whether they should see a paywall, and a paywall has thousands of variations. We check whether the URL they're on is a valid URL. We also check whether they're in a multivariate test of some kind. And we also have a whole GDPR infrastructure around their consent management, whether or not they should be served, say, ad cookies and tracking pixels and all of that. Now, all of these large services that run at pre-flight have downstream dependencies. So pre-flight is actually a bit of looks like an octopus. And imagine you have latency at any of these points, the whole thing just topples over and becomes like horrible to manage. And by the way, we've pretty much built every single microservice, including GDPR multivariate testing. We like building our own things. So if we have a knowledge silo there, then that makes it even more complicated to start to understand what's gone wrong. What pre-flight does is it's a task runner, so it can parallelize or chain tasks according to a config. So some of these things run in parallel, but the paywall, for example, depends on whether the user is authenticated or not. It depends on whether they should have access to a premium article versus a standard article, whatever resource they're trying to view. And we enforce something called performance budgets. So if the request to the whole paywall chain takes longer than 200 milliseconds, which is the performance budget for a paywall service, we just don't show the paywall. So we have to be super, super tough about what we enforce as a performance budget, and make sure that everybody still has a really good experience. So that's not always going to happen. Obviously, things get slower as we add more services. How do we keep that in check? So my colleague came up with this great term called microservice whack-a-mole. We have a monitoring dashboard for pre-flight, we have a monitoring dashboard for whatever relies on microservices anyway, but I've picked pre-flight as an example. And we look at the monitoring dashboard periodically, and we look at, okay, what's the slowest thing on here? So, anything that's sticking up, slowest one, just whack it, optimize it, until you get that thing down, and repeat until you've optimized it enough. And then pick the next thing that's the slowest, and whack them all again. Yeah, so I'm going to talk about how we optimize the paywall, whack a paywall, how we refactored it from the time it was the slowest thing at pre-flight. Okay, this is the Financial Times paywall. This is the front end, obviously, and it has thousands of variations. Depending on a user's IP, we can show them a corporate paywall that is specific to their organization. Depending on the geographic location, depending on whether they've copied content from ft.com. There are so many variations of this, and they all originate from the service, the backend service that underpins pre-flight. Paywall is kind of critical. We don't make money if we don't have a paywall. We lose money. So this is the architecture of how barriers get served on ft.com. So pre-flight calls the paywall service called Barrier Guru, and come up with that. This is fronted by Fastly, so the API itself is cached in a separate Fastly service. Obviously we route it separately, aside from the router that's downstream from pre-flight once the request gets restarted. The Fastly service for the paywall itself routes things geographically, using any cars depending on what's healthy. And then we go to the ft.com API, and we need to get various things from various places, like what offers the person should see, whether they're allowed a trial subscription, whether they already have an access license, whether they're a corporate client, etc., etc. So, where do you find what's slow? How do you find what's slow? How do you optimize it? First, we looked at how we make those requests to all the various services. And we thought about optimizing them. And no, this is actually really simple. This is a hack absolutely everybody should employ all the time. Pool your connections. Use Keep Alive on those fetch requests. This is what happens. I kid you not. Everything just goes down by half. It's brilliant. Geography matters. So paywall was very, very slow in the US, and we couldn't figure it out. Paywall, the API is Heroku. In the US, Heroku and the Fastly POP are actually closer together. So why is the US slower? We trawled to all the custom VCL code on our CDN, and we noticed that someone 9 months ago had done a load test and forgot to reinstate the US routing for the paywall, so all requests in the US were going around the globe to Europe and coming back, which is obviously putting extra strain on our infrastructure, and how did we not know for months? So yeah, sometimes it's simple things, it's uncovering mistakes, but think about geography and think, you might find some really obscure bugs in your DNS and routing layer that also have easy fixes, as they did in our case. Especially if you have, so one of the advantages of having micro frontends is that you can walk over to the team that built a backend that you need and say, do you know what, we don't really fancy going through the gateway, that actually adds a lot of latency. Can you give us a key on your load balancer, which is much closer to your origins, so that we shave off around 80 milliseconds. Now 80 milliseconds might not seem like a lot, but it all kind of adds up. So if we bypass the gateway and go to the load balancer and have these sort of political negotiations with the people who are building it, that happens again, slashed in half. And you can do things like minimizing your request overhead. what if you build some sort of proxy service that wrapped all of those requests in, say, GraphQL, and you had a way of caching them? Now, GraphQL requests, I don't know, are people familiar with GraphQL around here? Can I get a show of hands? Great, so you usually do them via post. But if you wrap that proxy in Fastly, and I know this is getting right to super deep magic level, write that proxy in Fastly, remember what payload you're getting for the post, and have a unique URL for that query. Then that gets cached by Fastly. So that's this is next level optimization. And then fundamentally, ultimately refine your caching strategy. So if you remember how now we're getting stuff from GraphQL, we not only just get stuff from GraphQL, which is another Fastly service, but we cache those responses in memory. So it's yet another layer of caching that you have to be very careful with. And the reason I explained why GraphQL has posts and then we kind of cache a URL, a unique URL against those requests to GraphQL, is because Fastly has a 200 item cache fragmentation limit if you just vary by, say, the post request itself. So it only ever remembered the last 200 requests. So all of these hacks caused a massive win for our paywall. We slashed the response time of the entire paywall itself by more than half and by almost 200 milliseconds, which is huge on every request on FT.com. But here lies obsession. So as I was getting towards the later optimizations, it was just getting a little bit too deep magic and a little bit too crazy. So please remember, measure everything and only make sure you optimize if you have an actual problem. So had the paywall been slower by 20 milliseconds, we wouldn't have cared. Okay, on to the dark side, the client side. Micro frontends also have their host of macro problems. Because every single service that we have on FT.com, every page is a different microservice. They all have the same challenges. And the challenges with front-end performance optimizations are twofold. The first one is reusing assets. So you reuse them between visits to decide and between page views in the same visit. That's the goal. And you also have to kind of lose the weight of the page, lose the weight of the assets, use responsive images, transpile less, polyfill dynamically, so don't ship more JavaScript than you need to for a client that has more features than another client. Using things like resource hints or headers, I'll explain in a moment what those are and how they work with browser, and inlining critical path CSS. So this is the Adios Money shopping list of what you should do if you're into front-end optimizations. The fact that we use Vanilla.js was a little bit of a win. It does take a lot longer to build things, but we don't have to worry about frameworks and the incremental impact of those on the front end. But we have 10 plus front ends, and having a strategy that optimizes assets and JavaScript bundles, anything that's shared between 10 front ends, is going to be complicated, to say the least. So what did we do? We built a performance thing. This is open source, so if you're curious, you can take a look at it. We built a big tool called NUI. It's a misnomer now because it does so many things. It is a content delivery network that serves assets unique to each app and also assets that are common to the FT as a whole. So you'll see that the header doesn't change much, the footer doesn't change much. It is a deploy tool for delivering assets to the CDN. So we round up all the JavaScript in the app shell, so the common bits, we round up all the JavaScript of that application, like an article page. We ship it off into the cloud and have some sort of versioning, so that Fastly knows which version to get back from the cache. NUI does this. This is a component that does this kind of stuff. Also handles the templates and asset loading and things like instrumenting metrics where they matter. So page clicks, page interactions, are all very automated. They're all in this tool called NUI. It's also the server with knowledge of all relevant assets and tooling. And it is available on NPM and Bower, and you have to use both. Okay, we're tied to Bower because Origami on Components Library use Bower because of the dependency flattening, but I won't get into that. So anyway, we have this thing called NUI that builds each app before the app goes into production, and we control a lot from NUI. And we thought it was brilliant when we built it. And other people didn't think it was that brilliant. Because what we have now is a very tightly coupled build system that is a server, that is a CDN, that is everything. And that sometimes breaks, and no one can fix it because the two people who had good knowledge of that have both left FT.com. So yeah, I'm sure you're familiar with that sort of problem. So maybe don't build the perf thing. Maybe you need a different approach. Anyway, we're stuck with NUI. In the meantime, here's what NUI does. This is a bit of magic. So FT.com has two modes. It's a progressively enhanced site. We have core mode, where we aim to deliver the full experience for all users, but without the bells and whistles of JavaScript and so on. And we have enhanced mode, so if the client supports more modern JavaScript, then we serve all our bundles. So it's either all or nothing. And this approach is great because it ensures that everybody gets a good experience. After all, we have a document. We're more on the document side of the spectrum rather than the application side of the spectrum. You can read the newspaper without having fancy buttons and so on. So this approach is called cutting the mustard. BBC coined this approach. Cutting the mustard just means decide on what set of features you need that the browser should absolutely have for it to be worth it for you to even serve your JavaScript. If that condition is met, then load the JavaScript asynchronously afterwards, after you've got the page and it's the DOM is rendered. Otherwise, just go back to whatever your core experience level is. We also have the polyfill service, which we built and maintain. So the polyfill is all that stuff, and we don't bother re-implementing promises every time we write front-end facing, client-facing code with promises. We get that from the polyfill service, and we get that dynamically. If your browser doesn't have promises, the polyfill service will recognize that from the user agent header and fill that in for you. So polyfill.io is really worth knowing. We have to keep our bundle sizes in check, so we have one CI if our application shell bundle starts containing too many dependencies, then you can't merge. Tough. Try and delete some. Same with the application JavaScript code, so the article page, if it gets too heavy, we just don't allow you to ship it. There's some other tricks like inlining critical path CSS, so basically anything that's above the fold when you open the page is CSS in the critical path. And to stop things from blocking and looking a bit janky, we put the CSS and the markup in a head tag. So that's the filament group. Adi Osmani also writes about this. This is a huge performance saving and can make like up to seconds of difference to your loading times. We use resource hints a lot, so you've got things like preload, prefetch, pre-render, DNS prefetch. These are very tricky to get right. So preloading a resource focuses on the next page that the user might see. So say if you're on a paywall, maybe the next page you'll see is sign up. So maybe you want to tell the browser to already get the assets for the sign up app and store them in its cache, so when we get to the sign up app, we don't have to wait for the JavaScript and CSS to download. Prefetch focuses, that's prefetch. Preload is on the current navigation. So maybe we're on the front page. We already know that you're going to need fonts. You're going to need the base level of CSS that makes everything not look nasty. So we preload and then push those assets through the pipe while everything else is loading. We can have DNS prefetching, so that allows the browser to perform DNS lookups on a page in the background while the user is browsing. We have pre-rendering similar to prefetching, except the whole page is rendered before the user gets the next navigation. And these things have to be judiciously applied to not lead to new performance degradations, because imagine if you just preloaded assets every time on every page without checking if they're in the cache, things like that. And I'm sure everybody is not a fan of third-party scripts. Unfortunately, we're a mature product with stakeholders, so we have to have various tags and advertising and so on. But we try and keep those in check by always looking at our request maps and trying to find the outliers and trying to renegotiate to see whether we can either get rid of it entirely or talk to them and see if they can make it better. Okay. That's the world, the lovely world of optimizing performance in FT.com. What's in the future? Wouldn't it be amazing if we could ship something called ES modules? So ES modules are, instead of having a bundle, everything that you need is a module in itself. Imagine like having a class. Rendered, not render time, at runtime you get a lot of saving by using modules. The new browsers are optimized. V8 deals with ESM so beautifully that you get huge performance optimization from using this approach. And markup itself comes with a sort of cuts the mustard for having ESM versus a fallback. So it's this script type module with script type no module. So you'd have the entry module that contains references and imports to all the modules you need in that client-side implementation, or then you have the big bundle that's the fallback. So yeah, it's really easy to implement. We thought, yeah, we definitely need to do this. Except we can't, because of this tool called NUI, we send resource hints server-side, right? Because we render everything on the server, because we're progressively enhanced, we also send resource hint headers. So we need to know at that stage whether we support ESM or not, and we can't do that with a script tag. That's the browser job. And then also we have a lot of dependencies that don't yet ship ES modules. There are some, like Babel plugins, for example, that could convert CommonJS to ESM, but they're brittle from our experience, so we're not there yet. But because we like a good hack, we've decided that we're going to ship ES6 to a proportion of users that support the more modern JavaScript and just transpile way less and polyfill way less. And from looking at our data, it is actually worth it for us to do this. So how are we going to hack this together? We use Webpack to bundle our front-end assets. We simply bundle twice. We have bundle in parallel with Webpack, so we have the normal configuration that is, this is the sort of the browser support that we aim for, this is how much you're going to Babelify, this is the preset, etc. If this all sounds like foreign language, please feel free to ask me later. In parallel with that, we also bundle a much more lightweight, we also process a much more lightweight bundle with minimal transpiling. So okay, maybe you don't need to re-implement fetch, we're not going to get the regenerative async await. These are up to 50% lighter if we just say, do the big JavaScript, but also for the modern people, do the smaller bundle. But how do we then handle the fact that we have to render everything server-side? So we can sniff the user agent at the CDN and decide in a really roundabout way whether the user agent is in a browser's list that supports ES modules or not. And then, depending on that, we can cut the mustard. So, do we support ESM, then ship the ES6 bundles. Otherwise, ship the base bundles using resource hints. So this is all a bit of CDN magic. We're not quite there yet. We're going to do it. Hopefully by the time we actually get around to shipping this, we will have solved the ESM problem and won't have to do this huge roundabout way where we need to sniff user agents over CDN and so on. The other thing that we're considering in the future is anything that's one-shot versus continuous. So right now we'll do a performance audit, as in someone looks at a dashboard or someone runs a test using web page test and we draw some conclusions and we optimize some things. But actually, you can be a bit better than that. You can bake in performance optimizations at CI. And I was thinking about this, and it turns out there's lots of ways to do it. And we're going to go ahead and see if we can use something called speed curve on continuous integration. That actually deploys the site and runs some speed curve audits on it, and can come back with, fail or succeed at CI. If you use things like Chromium or Puppeteer, even if you don't, you can spin up custom lighthouse audits for micro frontends. So anyone who's used Chrome DevTools to do performance optimizations is maybe also familiar with the Audits tab, where you can run a tool that ships with Chrome called Lighthouse that audits based on a checklist the page that is currently in the browser. So that can be automated. You can spin up a headless browser, you can have a Lighthouse audit, and you can then decide to fail that build based on your performance metrics. So you can essentially have front-end performance budgets. Other things. We're not going to do this, but it is a fun idea. So Gas.js is a library that sort of learns what the path will be in the user experience, so what pages users visit and in what order, and then makes decisions on sort of dynamically bundling things based on what kind of user you're likely going to be. It's fun to experiment with. We haven't proven that it provides advantages over us deciding, okay, so this should be the app shell because everybody has a header and a footer, and the rest of the code you just deal with yourself, we trust you. But it's an interesting idea. It doesn't work for us. But why? Why should we even bother with all of this? Why do we have such a complicated ecosystem of microservices? Our front end has this tool that we cannot uproot without rebuilding the whole thing. Why do we even bother with performance? Because it's an accessibility issue. This is why everyone should bother with performance. I'm going to finish with this wonderful website built by Tim Kadlec. It's whatdoesmysitecost.com. And it uses web page tests to measure the weight of your page, and it translates it in money around the world. So, mobile data, what does it cost to visit my site from Mauritania or Botswana? Or, turns out ft.com is really expensive to visit from Canada if you're a Canadian. Right? We thought Canada's kind of important on our list of users, one of our the second biggest consumer is the US. And whatdoesmysitecost.com also looks at, relative measures like percentage of daily income. So run your page through that and understand how inaccessible you are to your customers in countries. And it's like an empathy building tool. It also helps with justifying performance optimization time to stakeholders. So yeah, what was all this about? What you should take away. So, how we choose to build complex things is really important. Also not easy. And these choices that we make to be able to develop products that are stable quickly and reliably will not always be good for web performance. So NUI helps us massively. It is critical to the way we build ft.com, but it is also a huge problem for web performance. So microservices, all of these decisions, they have a weight, and you have to find compromises between your decision. That takes thought and effort, and a very healthy relationship with failure. And you can be a long way from perfect. We're not perfect, we're a long way from perfect, and we still get great results. Those are the words of Rhys Evans, my colleague who built NUI. I thought he deserves a shout out. So that's me. Thank you very much.
Oh, thank you very much. It was really interesting talk, and I actually tried ft.com, and it was really fast. So thank you. It's really a pleasure. So, any questions?
I have a question.
Okay.
Sorry.
Very English, but I recall that you have around 1,000 microservices.
100.
100, okay, 100. It's like a Netflix, or each other like this. And can you explain one or two examples of microservices and their area of usage? So, one or two. Thank you.
Yes.
Why a new site requires so much architecture in microservices?
Okay, I'll explain one that I'm very familiar with. I already went through the paywall, so not all of those microservices are within our control. We split up our areas based on features. So we have the paywall, that's a feature. Maybe we need to share some of the code of the paywall, so the paywall needs to know about whether the user has access to a resource or not. That's a shared microservice with pre-flight, that's a shared microservice with a few places. Lots of features need to know whether the user has access to them. The paywall also needs to know that. So there's microservices that are shared, and there's microservices on the paywall that don't get used very often, such as there's a Lambda that sort of polls the latest pricing information every day. We know that doesn't get updated every day. It's not. We don't want to put a Fastly service around it and worry about all that. We just have a polling Lambda that updates some JSON data somewhere. So that would be the domain of the paywall. Another thing is GDPR. So GDPR architecture had to support not just FT.com, but a lot of other titles, some of which are not on the FT domain. So we had to build a pick and mix structure of microservices, some of which will be used, some of which won't be used, some of which are maintained by our team in Sofia, some of which are maintained by FT.com, some of which are maintained by my new team in the internal apps department that I now work in. This would be very tricky with having a big monolith, and we prefer building things in Node. In fact, in London, we are kind of going more and more towards JavaScript. While some of the Platinum services we've now handed over to our team in Sofia, which is a platform team, are written in Elixir and Go. So it really helps with a lot of separations of concerns and a lot of reusability. And it also plays a part in the fact that if you have a microservice, you can shift it around quicker, and you can have an SLA just on that, and you can think about how you degrade gracefully if it doesn't work.
Okay, more questions?
Let me extend the previous question. So, as you mentioned, you have microservices architecture and it's vertical stack. So you have microservice back to frontend. And microservice can be independent. You can independently test it in isolation, which it works. But when you go to frontend, as you mentioned, you have titles and other elements which will cross-dependent on frontend level. So you pick up data from multiple microservices. You mentioned you don't have a great team. And at the same time, you have frontend which integrates on multiple microservices. So you either should have extensive integration testing, or you should have some magic around it. How do you do it?
Bit of both. So we have a dedicated engineering test team who write shared automated testing tooling. So we have a base level of smoke tests that you have to pass. We have things like accessibility testing that everything has to pass on a CI. Those are not options, those are bundled with your front end built tool, which is, evil, but let's just stick with it. And we get around it by having a lot of shared tooling. So the web performance at the FT is very much a philosophy as well as a process.
And I saw your screenshot, there was about 1 hour between commit and production. If it's true, does it mean that you are able to pass through the whole CI cycle, go to confirmation and use it?
Yeah, if the test suite passes, then you go straight through. And we have that for absolutely everything apart from the CDN and pre-flight. The CDN has a staging environment, and pre-flight has canary releases where we release to a fixed percentage of traffic, which is 5%. We have separate monitoring for that, and we can see comparatively soon enough whether it's a good thing or a bad thing that we've released. Everything else goes straight to production, and thanks to Heroku, we can just roll back if it's broken.
Thank you. Everyone pushed in production directly, at least once.
Thank you, Dora. What do you use for testing visual part of frontend?
We use Browser Stack. We use Source Labs on Source Labs with Nightwatch on the sign-up form, and for everything else we use Headless Frame.
More questions? I think it's the last question because we don't have much time.
What databases do you use, and what about infrastructure? Do you have some centralized database cluster, or maybe one database per server, or per service?
It really depends. So the data stores themselves are almost like microservices. We have a shared store that stores consent for everybody in the FD group universe, not just FD.com, that a lot of places use. We have, that is, I think, Dynamo. We have a lot of Neo4j in various places because the way articles are structured hierarchically by topics and so on. So the content platform relies on Neo4j. MyFT, where the user can create personalized journeys, that relies on Neo4j. So yeah, it's the bulk is Dynamo, Postgres, and Neo4j, and there are some other sort of minimal uses of other data store technologies. We've written our own data pipeline that relies on VaultDB, which is an in-memory store if we need access to information. So, for example, we need a user's browsing history for the past 7 days. That's in VaultDB. And everything from VaultDB passes through to AWS Redshift, which is the big data store where it forgets nothing, but it takes 24 hours to get it.
Thank you again.